Hi, seventh graders. Today we are going to continue talking about transversals. And so, a quick review that a transversal is a line that intersects at least two other lines in the same plane. So, on Friday, when we started taking our notes, I had you guys kind of color in the transversal. So, we have two lines, and then the transversal is the line intersecting at least the two other lines, okay? We talked about several different pairs of angles on Friday. We talked about vertical angles and reviewed those. So angles that are opposite of one another when lines intersect. So that would be like angle 5 and angle 7 would be an example of vertical. We talked about alternate interior angles. So remember, interior means you're in between the lines, okay? And then the alternate means that they're on opposite sides of the transversal. So for example, 5 and 3 would be alternate interior angles. 8 and 2 are alternate interior angles. We talked about alternate exterior angles. So exterior meaning you're on the outside of the two lines that the transversal is intersecting. And so alternate exterior would be 6 and 4 and 7 and 1. Same side interior. Interior again means we're in between the lines. So same side of the transversal, so that would be angles 2 and 5, and then 3 and 8. And then same side exterior angles, again, we're on the outside of the lines. And so same side of the transversal, so 1 and 6 and 4 and 7 would be your same side exterior angles. We have one more type of angle to talk about, and then we're gonna talk about what happens if we have parallel lines intersected by a transversal. So we're going to talk about corresponding angles. That'll be our last relationship that we're going to talk about today. So corresponding angles are going to be angles that angles on the same side of a transversal that kind of slide to the matching location on the other intersecting line. So they kind of match up. So and it's kind of hard for me to give you a good visual when I'm not there in person, but for example, if I were to take this line and if I were to slide it down on top of the other line down here, then I'm looking for which angles match up. So like angle 6 and angle 2 would be corresponding angles. Okay, they would kind of line up if I were to slide that second line down on top of the first one. Angle 7 and angle 3 would be corresponding. Angle 5 and angle 1, and angle 4 and angle 8. Okay, so those are all some different examples of corresponding angles. I'll give you guys, if you can go ahead and pause the video to get that definition down. Now we're going to talk about what happens when we have transversals and parallel lines. So first of all, a little reminder that when two lines are parallel, they're going to give us some kind of visual cue to tell us that lines are parallel. So usually those are some sort of arrow on the line. So it might look like just like kind of that little arrow there, or sometimes it might be like a solid triangle arrow. So those are both examples of ways that we might be shown that two lines are parallel. Remember, we don't really want to assume something unless we, in geometry, we don't want to assume something is parallel or something is a right angle. We want to look for a visual cue or a measurement that proves that. So when we have parallel lines crossed by a transversal, we still have all of those different angle relationships, but now there's something else that happens with those angle relationships. So if lines M and N here are parallel, then what that means is that angle 3 is going to be congruent to angle 6. So our alternate interior angles are going to be congruent, and angle 4 is going to be congruent to angle 5. So because those lines are parallel, now our alternate interior angles are congruent. We also know if M and N are parallel crossed by that transversal, that angle 2 and angle 7 are going to be congruent, as well as angle 1 and angle 8. And so those are going to be our alternate exterior angles. Our corresponding angles are also end up being congruent. So again, corresponding would be like if I took line M and if I were to slide it down on top of N, the angles that match up. So angles 1 and angle 5 match up and are corresponding. Angle 2 and angle 6 are corresponding. Angle 3 corresponds to angle 7. Angle 4 corresponds to angle 8. And so because if M and N are parallel, that also is going to tell us that that did not work at all, sorry guys, that all of those angles are congruent as well. So angle 1 is going to be congruent to angle 5, and angle 2 is congruent to angle 6, angle 3 is congruent to angle 7, and angle 4 is congruent to angle 8. Remember, congruent, the symbol here that I'm using is that little equal sign with the little wave on top of it. So that means congruent, and congruent means equal. So our same side interior angles, there's also relationships that exist between those now that M and N are parallel. So when we look at our same side interior, remember we're inside the parallel lines, same side of the transversal. Okay, so like angle 3 and angle 5. What's going to happen there is they are going to, let's see if I can get this to work, be supplementary. Okay, so angle 3 and angle 5 will be supplementary, and so our angles 4 and 6. Oh my goodness, sorry guys. So your alternate, your same side interior angles are going to be supplementary, as are your same side exteriors. So 1 and angle 7 are going to be, angle 1 and angle 7 would be supplementary, and our other same side exterior, angle 2 and angle 8, are also going to be supplementary. So because of all the different linear pairs and the vertical angles, what ends up happening is all of our acute angles in the diagram end up being congruent, and all of our obtuse angles end up being congruent. And so how we can show that angles are congruent is using like a little arc. Okay, so I'm going to say that angle 1, all right, between all of these different relationships, like angle 1 is vertical to angle 4, so I know that those two are congruent. Angle 1 corresponds to angle 5, and I know that because M and N are parallel lines, then my corresponding angles are congruent, which also tells me that angle 4 is going to correspond to angle 8 and be congruent with angle 8 there as well. Okay, and if you look, this also is a good example to show you that your alternate exterior angles end up being congruent, as well as your alternate interior angles being congruent. And then all of our obtuse angles are also congruent. And so sometimes to show that a second type of angle is congruent, you might either see different color, or sometimes you might see a double arc. I'm actually going to use the double arc here. All right, so angle 2 and angle 3 are vertical angles, which means that they're congruent. Angle 6 and angle 7 are vertical angles. All right, and then again, the connection between those is like angle 2 is corresponding with angle 6, and because lines M and N are parallel, then angle 2 is congruent with angle 6. Or you could also look at it as angle 6 is an alternate interior with angle 3, and so now that makes them congruent, which also helps us know that angle 7 is congruent to angle 6. So a bunch of relationships have been formed now that we know that those two lines are parallel, okay? So the converse or opposite is also true. So if each of these bulleted statements is true, then that tells us the lines are parallel. So if we were to know that our alternate interior angles are congruent, then that would be indicating that the two lines are parallel if we didn't already know that. So here we're going to just name some different angle relationships and then solve for some missing angles as well. So on the far left example over here, we have two lines crossed by a transversal. Those are not parallel lines. Now, there's still different angle relationships there. It's just the different pairs of angles aren't necessarily congruent. So angles 1 and angle 8. So here's my transversal. Angle 1 and angle 8 are on opposite sides of the transversal outside of the line. So those would be alternate exterior angles. Angle 3 and angle 7 would be corresponding angles. And then angles 5 and 8 are vertical angles. On this next chart, it says fill in all the missing angle measurements, and we're told that the angle up here is 75 degrees, okay? So I want you guys to pause the video and see if you can figure out what the different angle measurements are. And so as we go through and we figure out these different angle measurements, we can start to use all of the different angle relationships that we know about. So for example, I know that this 75-degree angle is going to be supplementary with this angle, which means that they're going to add up to 180. So that tells me that this angle is 105 degrees. Then I might say this 105-degree angle because, sorry, so these two little arrows here again are telling us that those lines are parallel. So now that we know that they're parallel, all of those angles become congruent with other angles. And so this 105-degree angle would be corresponding to this angle down here, and I know that my corresponding angles are going to be congruent. Then I might say, well, I know that this is an alternate interior with this angle, which tells me that that angle is 105 degrees. You could also see that these two are vertical. These two are vertical down here as well. And then our other angles, so like that 75-degree angle is vertical to that angle. This one corresponds down here. And we also have either vertical angles this way or alternate interior, again, to tell us that that's 75 degrees. On this example over here, it says fill in all the missing angle measurements. So again, I just want to point out that we're being told that these lines are parallel, so that's what helps us and allows us to know that we're going to have a bunch of congruent angles here, okay? And so same idea. I have a 36-degree angle, so I see that that's going to be vertical with this. And then I could say it's an alternate interior with this angle, which is vertical to this angle, which is another alternate interior between the next set of parallel lines. And then it's vertical there, okay? Again, we also have corresponding angles that could help you see that relationship. And you could even use some alternate exterior like with this one and this one. Then because we know that this angle is supplementary with that angle, so if this angle is 36, then that means that this angle should be 144 degrees. And then we're going to use all those different relationships also. So I know that's vertical with this angle, alternate interior with this angle. This one corresponds to this one. We have another alternate interior angle. We have vertical angles. So there's a variety of different relationships that can help you. So again, it's going to be kind of like a puzzle. Like once you know one angle measurement, if you have parallel lines that are being crossed by a transversal, if you know one measurement and one angle measurement, you should be able to solve for all of the angle measurements. So this is kind of our mild type problems that you might be having where you're just given a number value and then you need to solve for the other angles. How it'll kick up a notch tomorrow will be